Dr. Calvin, one of the things that our committee's been focused on is the growing concern about orbital debris. Is there a threat posed to the Landsat program by growing amounts of orbital debris? Is this something you are focused on?
So at NASA, people think about this, and we agree that it's important to ensure that space is usable for years to come. Space debris and mega constellations are an issue that need to be addressed by U.S. leadership, and I think I can refer other colleagues within my agency for more information on that.
Thank you very much. Dr. Abdulati, being from the West, you know well the dangers of not only drought, but also some surprise flooding from snowpack melt. In Wyoming, we saw a lot of damage this spring around Yellowstone National Park, where we had surprisingly rapid snowmelt due to some unseasonably warm weather and rain simultaneously. And so are there ways that Landsat can help mitigate these sorts of disasters?
Well, the mitigation, what we can do is observe as they unfold. So we can mitigate the management of those kinds of disasters and preparation. And it's not just Landsat, it's other observations, because it requires understanding the potential for rain. You know, how much water is in the atmosphere, how much is going to fall out, how much snow, we call it snow water equivalent, is stored in the mountains. So you mentioned rain. Rain makes melt happen much faster. It's a much more efficient energy delivery system for melt. So it really requires the monitoring and forecasting of rainfall, temperature, the rate at which it'll occur, the topography, because the runoff of the water dictates or is a big driver in flooding as well. So all of those elements combined. Certainly Landsat is a component of it, but there's much more to be observed.
Thank you. Mr. Gallagher, as you know, Wyoming is rich in oil, gas, coal, uranium. It's my understanding that using images from Landsat, we were able to determine the subsurface composition of minerals and other deposits based on above-ground particles. Certainly it's true with uranium. We see that in Fremont County, Wyoming, as well as some other counties. How's the data collected by Landsat's program making our natural resource location and extraction more efficient, pinpointing it a little better?
Good, thank you for the question. So yes, it's true that the superficial geology, if you know the superficial geology, then it can tell you whether or not it's complementary for minerals and oil and gas. Landsat has some spectral bands that provide some certain information about the surface. More broadly at USGS, we have other sensors that can do that as well. So in my mission area, I partner with the Energy and Minerals mission area on a project we call Earth MRI. So we're flying airborne instrumentation that is electromagnetic data that lets us see us into the subsurface for the identification of critical minerals. So I just cite that as an example. There, as my colleague said, there are really multiple sensors that give you that kind of information both on the surface and subsurface, and Landsat has a role.
Thank you. Dr. Voles, are you still there? Can you hear me?
You're unmuted. Yes, I can hear you fine, ma'am. Go ahead.
Great, thanks. I want to expand on a question that was asked earlier. Are there data sets that can be used to help us combat wildfires in real time? As Chairman Hickenlooper stated, you know, if we can catch them early enough, we can really contain the damage. And I'm curious about whether data sets can be used in that way.
what Dr. Abdullati just said a few minutes ago. Sorry.
Yeah, we're getting a lot of feedback.
Sorry, I'm say yes.
Okay, good. You answered my question, and yes, and then you referenced Dr. Abdullati's name. So I wonder if I might turn to him to elucidate a little bit.
Yeah, I'm sorry. Can you restate? You're asking if there are data sets that
Yeah,
can be
that
used?
can help us identify in real time wildfire potential or.
Oh, certainly. You know, and in fact, I personally, my neighborhood was destroyed by the Marshall Fire in Colorado. We lost 1,100 homes. Mine was not one of them. There was a lot of smoke damage. But personally, as we were evacuating, I with my daughter and my coughing dog, I just looked around at how dry the land was and felt the wind, you know, and so it's information on wind speeds, it's information on drought. Soil moisture is key because while it was a likely human-ignited fire, as most wildfires are, the conditions for it, the fuel for it, were in the dryness of the soil and the vegetation, the winds that just caused it to rip through the neighborhood, the area. So data sets are soil moisture, information on vegetation, so we understand its health, how dry it is. Is it kindling or is it, you know, green? Winds, precipitation, and all of these can be derived from, not solely or exclusively, but from satellite observations, as some of which were mentioned here. Landsat is a great element of that system, but there are also things like forecasting winds and understanding soil moisture and other data sets. So yes, it's an integration of capability.
Thank you. And can I ask one more quick question? Do I have time for that? Mr. Jablonski, is there a way the private sector can work with the public sector's data sets and information to provide even more information?
Thank you, Senator. Absolutely. For example, on a private sector satellite, WorldView 3, we have over 20 multispectral bands, including shortwave infrared sensors. And those shortwave infrared sensors can actually see through the smoke to determine the boundaries of a wildfire, where the hot spots are, and help the teams on the ground best determine. It can also tell you when you think you've got a fire out, where you still have localized hot spots that you might need to take care of or work on. And then Maxar and other commercial companies have weather desk type abilities. So for example, our weather prediction capabilities are used commercially, but can also be used by governments to determine crop health, to figure out economic indicators, and in areas like this, think about what a propagation pattern might look like in a localized area.
Thank you, panel. Really appreciate your testimony.